Today we're going to be proving that a quadrilateral is a parallelogram. So theorem 6.5 states that if both pairs of opposite sides are congruent, then the quadrilateral is a parallelogram. So if both of our opposite sides are congruent, we know that they will be a parallelogram. Theorem 6.6 states that if both pairs of opposite angles are congruent, then the quadrilateral is a parallelogram. Theorem 6.7, if the diagonals bisect each other, then the quadrilateral is a parallelogram. So if each of our diagonals bisect each other, then it's a parallelogram. And the last theorem, 6.8, states that if one pair of opposite sides is both parallel and congruent, then the quadrilateral is a parallelogram. So if they're both congruent and they are both parallel, then we know that our figure is a parallelogram. So in example 1, we're finding the values for parallelograms. So if ON equals 4x minus 6, and the length of LM equals 3x plus 5, NM equals x minus 4, and the length of OL equals 4y minus 3. We also know that angle O is 3z plus 10, and angle M is 7z minus 34. We want to find the values of x, y, and z for which that L, M, N, and O is a parallelogram. So to first start solving, let's look for solving for x. So I know that my opposite sides are congruent, so I know ON is congruent to ML. So that means I have 4x minus 6 equals 3x plus 5, because these two are congruent to each other. So I'm going to subtract 3x from both sides. So 1x minus 6 equals 5. Add 6. So I know x equals 11. I also know that my other sides are congruent to each other. So I have 4y minus 3 equals x minus 4. I just found and solved that x was 11, so I'm going to replace my x with 11 and solve from here. So 4y minus 3 equals 11 minus 4, which is 7. Add 10 to both sides. So we end up with 4y equals, add 3, not 10. 7 plus 3 is 10. So we can divide both sides by 4. So y equals, if I reduce this, it's 5 halves. So y equals 2.5. So lastly, now we have to find and solve for z. So we also know, since this is a parallelogram, that our opposite angles are congruent. So we have 3z plus 10 equals 7z minus 34. So I can subtract 3z to both sides of the equal sign. So 10 equals 4z minus 34. Add 34 to both sides. So 44 equals 4z. And divide both sides by 4. Z equals 11. So in example 2, we have OH is 2x minus 7. OF is x plus 3. EG, so this whole diagonal is 4y minus 2. And then OG is y plus 10. So we want to solve for x and for y. So first of all, since I know this is a parallelogram, I know my diagonals are bisecting each other, so that means that 2x minus 7 is congruent to x plus 3. So I can subtract x to both sides. So 1x minus 7 equals 3. Add 7 to both sides. X equals 10. So I solve for x, now we have to solve for y. So in this case, we have our whole diagonal, which is 4y minus 2, equals, well, since it's the whole thing and we know these two are congruent, we also know that EO is y plus 10. So that means I have 2y plus 10. So when I distribute that 2, I end up with 2y plus 20. Subtract 2y from both sides of the equal sign, so I have 2y minus 2 equals 20. If I add 2 to both sides, 2y equals 22. Divide both sides by 2, y equals 11. Alright, for example 3, we have find the values of x and y for which ABCD is a parallelogram. So again, we are working with our diagonals, and since it states we are a parallelogram, we know they're bisected. So we know that the 5y minus 6 is congruent to x plus 2, which we can't solve that one first because we don't know our x or our y. So I also know, though, that 3y plus 3 equals our other bisected length, which is 4y minus 8. So if I subtract 3y to both sides of the equal sign, we have 3 equals 1y minus 8. So I can add 8 to both sides. So 11 equals y. So now that we know y, we can solve for x. So I can take and replace my y with 11. Oops. X plus 2. So 5 times 11 is 55. Minus 6 equals x plus 2. 55 minus 6 is 49. Equals x plus 2. So we subtract 2 from both sides. So 47 equals x.